Hello everyone, in this lecture we are going to learn about different types of YouTube configurations. Our flagship courses are Master Static Equipment Design and PVElite, ASME Section 8 Division 2, and Master Welded Storage Tank, as per API 650. We have curated courses to suit your learning needs, so do visit our learning platform for more details on scutoid.thinkific.com.
So before we understand how to calculate the thickness of a tube sheet, let us try to understand the configuration. Okay, because based on configuration, your calculation will follow. Okay, configurations are pretty simple. Don't worry about that. So first of all, I think you know this is the typical sketch for a YouTube type heat exchanger, right? Well, this is the channel side, shell side, BEU. There is pink color is the tube sheet. Okay. Now this is one configuration which you see here. We'll talk about this. So there are saddles, nozzles, lug attached to that. Simple configuration. Okay. Now, once I say we are going to talk about configuration, then basically what we are going to talk about is this: how the tube sheet is connected with channel side and also the shell side. Okay. So this configuration, basically your channel is having a flange, your shell is also having a flange, and your tube sheet is sandwiched. It's not integral. When it is integral, that means welded. Okay, so integral word in code means welded. So once it is integral, so either it will be integral with channel, then it will become channel side integral. Second, it may be even integral with shell side. Okay. So we'll talk about the different, because that is also possible. You'll say, why not? Why not to weld this tube sheet, make it integral with the channel? It is possible. That configuration is also possible. So that is what we are going to talk about. Okay. This is the first configuration. What exactly this is? Double integral. So integral with shell also, integral with channel also. Right. So this is channel. This side is shell. Okay. And this is my tube sheet. Okay. So it is welded. That means it is integral. NEN. So that is what we are talking about. Basically, this is one way. My tube sheet can be attached to shell and channel. Okay. So completely welded, both side integral. Okay. Now, what can be? This is the configuration A. Just remember the configuration name. So configuration A means both side welded. What do you think configuration B will be? Just for curiosity, what will be configuration B? If configuration A is both side welded, what can be the second variation? It can be one side welded. Okay. So one side may be channel side. So, or it can be shell side. So both variations. So if B is shell side, then C might be the channel side, right? I hope you're able to get this. Okay. So channel side also may be other variation, but don't know whether C or something else. Okay. So we'll see that. So B is a tube sheet integral with shell. So we will bolt it and our configuration is ready. Okay. Don't worry about dimensions. Now C, still it is integral with shell, but what is the difference between B and C? Lap joint. Okay. So in B, the tube sheet was extended as flange. So in B, it was extended as flange. In C, it is not extended. It is a lap joint. It's not sandwich type. It may be split ring. Okay. but it is not a sandwich type, because sandwich type definition is what we saw in the first one, right? That will also come. So this is type C. Okay, I hope you got it. See, there are different terminology, lots of terminology we are using. So you don't have to remember, just try to see, what are different variation possible, and then we'll try to form some logic. See, these calculations and the formula which you see, which are going to come, they are really difficult to understand, that to get meaning out of it. Okay, because we as an engineer, if we see a calculation, like we see a bending formula, we try to relate, okay, this is how the bending is happening, and there will be stresses at the top, there will be tensile, bottom it will be compressive. So we try to understand the formula, right? Once the formula becomes bigger, it becomes really difficult to extract meaning, so that we understand what exactly they are trying to do. So tube sheet, integral with shell, but not extended as a flange. That is my C type. Okay. Now D, sandwich tube sheet. Okay. Tube sheet is not extended, right? There are flange. So flange is different. The nomenclature is based on tube sheet. Okay. You try to notice that. So definitely there are flange. They have to be flange. Two flange has to be there. Then only we'll be able to bolt if you're doing bolting. Okay. So in first configuration, it was completely welded, so no flange was there. Other than that, we see always two flange. So either my tube sheet will be extended and will act as a flange, or there will be two separate flanges like we see now. So this is my D type, bolted. Now in D type, there can be two different types. First, where we saw the first figure, okay. If you see slightly change here, so here my tube sheet is just up to this point, up to the face. You will see the configuration. If you have gone through TEMA, this is this creates a confined joint. Okay. Now it may happen that it is extended. Okay. Now why sometimes we may prefer extended? There are reasons for that. We'll see that, but don't complicate here. There can be two different configurations. Why sometimes we use it at extended. That is the hydro. Okay. The B will be having two variation. One is just a tube sheet, and second is extended. Great. Now E type. Now we are going in the opposite direction. Okay. That is, now the tube sheet is integral with channel. This configuration, just by if I say tube sheet integral with channel, you should be able to draw this configuration. Okay. So you don't have to remember, just by knowing the name, you'll be able to draw. If you understand integral means welded. Okay. So this is type E. Now F, opposite to C. Okay. Where the tube sheet is integral with channel, but there is a lap type of flange which is there. Okay. So it will be bolted. So this is F type. Now, what are the common configuration for a YouTube? Okay. Now, if you try to figure out whether we can have all the configuration possible for YouTube type heat exchanger, whether I can have all the configuration which we saw. It is given in code, all the configuration for YouTube. But in practically, can we have? See, you may have something which is may use, but commonly but the code is very generic, so it gives everything. Okay. But which one will not be there? If we talk about this, can I have a YouTube configuration with F type? Yes, no? Can I have? Yes. Great. Yes, we can have. Can I have C type? Yes. Can I have E type? Yes. Can I have this D type? D type, anyway, we saw it is possible. C type. Can I have a C type for YouTube heat exchanger? See, if I have a YouTube, definitely, see, if it is given, it can have, but practically in most of the cases, what will happen? See, if this is a YouTube tube bundle, we cannot take it out, right? Tube bundle removal will become problem. So, no, we will not be able to clean that tube bundle. Okay. So very rarely you will see, but it may find some uses, some application. We don't know. So that is the reason code is given, but this is not what you see typically, the C type. Okay. So basically all this configuration where tube sheet is integral with shell, that become doubtful for your U bundle. Okay. When you are talking about U type heat exchanger, all this A, B, C, when it is integral with channel, that is possible. Okay. But that type, you will always try, like if this is my configuration, let us say this is my configuration, what type of joint will be there in this, whether you use a descend or you will use a flange with blind cover, dish or flange. See, simple. If I provide a descend, then how will be able to access my tube sheet? This tube to tube sheet area will completely become blind. Okay. So we'll try to use, if we are using a bolted connection, we'll be able to access, right? So we can clean, we can replace tubes. Okay. If it is YouTube, it becomes, it is not possible to replace, but at least we can do plug-in. Okay. So all those things. Okay. So all logic, nothing trivial.